Welcome everyone to what I like to call One Earth, Two Fates. And I have a question for you right from the start. What if Earth suddenly decided to change the rules of the game? One side drops gravity by half, the other side doubles it. What happens? Well, this question comes from Jack, one of our viewers. Jack wants to know if humanity would survive or if we'd all be flattened into pancakes. But wait a minute, before Jack and I start debating who'd look more like Dwayne "The Rock" Johnson, let's actually look at both sides of the screen. Left side, half gravity, half. Let that sink in. If you weigh 70 kilograms, you're now 35. You walk like you're floating on the moon. That's why people there are 3.5 meters tall. They're basically human skyscrapers. They glide. They're buildings, 120 stories of needle-like elegance. Trees grow 30 meters high. Rain? It drifts down in slow motion like a nature documentary shot at 120 frames per second. Now look at the right side, double gravity. Your 70 kilograms becomes 140 kilograms. People there are under a meter tall, short, stocky, like walking refrigerators. But come to think of it, they're strong, incredibly strong. But walking feels like carrying a 200 kilograms backpack everywhere. Every step leaves a permanent footprint. They're trees, 4 meters tall at best. Squat, dense, like mushrooms on steroids. Rain? It falls like gravel, heavy, fast, and splattering hard enough to leave craters in soft ground. Now, scientifically speaking, because I know Jack loves numbers, this isn't just about height or weight. This changes everything about how life functions at a fundamental level. According to geothermal data from Southern Methodist University's Geothermal Laboratory, when gravity doubles, atmospheric pressure increases exponentially. At 2.5 atmospheres of pressure, oxygen becomes toxic to the human nervous system, causing seizures. That's why the right side is short, heavy, and sluggish. Their bodies are fighting conditions harsher than anything NASA has ever recorded on any known exoplanet. Conversely, on the left side at 0.5 grams, air density drops significantly. Temperature drops about 35 degrees Celsius per kilometer of altitude following the dry adiabatic lapse rate. That means the top floors of those 120-story needle towers, frozen solid. Bottom floors, comfortable. But here's the kicker. That extreme temperature gradient creates massive thermal winds, strong enough to lift a 35-kilogram person straight off the ground. So Jack, and you know who you are, the way you ask that question makes it pretty clear that you're probably stuck in that gravity well yourself. But hey, I don't blame you. Who wouldn't be curious about whether they'd be floating like a feather or stomping like an elephant? But here's the thing, if you watch closely, really closely, look at both halves of this world. On the left, everything reaches upward, tall, light, buoyant, optimistic. On the right, everything presses downward, short, heavy, dense, persistent. Come to think of it, which world are we living in right now? Is life's gravity pulling you down, or are you being lifted by opportunity? And I'll leave you with one final question for all of you watching. Between these two worlds, the world that floats and the world that stomps, which one would you choose to live in? Drop your answer in the comments. I'm genuinely curious.